Let me write it down. So 13 or 9, 1. Okay. So 13, 5x plus 8y. 5x plus 8y equals what does it equal? Negative 58, and then 2x plus 2y equals negative 18. Now, we're doing this, but I'll let you know on what the obstacles are for this type of work. So anyway, so this is equation 1, this is equation 2. So again, we're going to do the same. We're going to work separately for each of the two equations. And again, it's a linear function, so we're going to bring it to the slope-intercept form in the form of y equals mx plus b. So work with equation 1. So I have 5x plus 8y equals negative 58. So 8y equal, I'm solving for y, obviously, so negative 5x minus 58. Okay, so I divide everything by 8. Okay, and then I get y equals negative 5 over 8 x, and then minus 58 over 8. And apparently 8 is not a divisor for 58. In other words, 58 is not a multiple of 8. So 56 would have been a multiple of 8, because 56 divided by 8 is 7, right? But 58 is not a multiple of 8. So we're going to leave it as is, and it's a little bit unusual, so we're already getting in trouble in a way, and I'll tell you exactly what we mean by that, what I mean by that. So again, we brought it to this form. Okay, so here's the slope, and here's the y-intercept. Okay, so work with equation 2. So I have 2x plus 2y, okay, and then equals negative 18. So 2y equals negative 2x minus 18. So this is going to turn out much better slope-intercept form. So divide everything by 2. So you get y equals negative x minus 9. Okay, so again, notice the mx plus b. So the slope is negative 1, and the y-intercept is going to be 0 and negative 9. So for this one, is going to be 0 and negative 58 over 8. Okay. So again, let's give it a try, but I guarantee you we're not going to get the correct answer. And I'll tell you. I keep saying that, but yeah, I'll tell you in a second. So here is our x and y coordinate at 0. And let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. Okay. So one line, the second one is going to pass, is going to cut through negative 9. So notice that the slope equals negative 1, or negative 1 over 1, which means rise over run. So you're rising 1 and running 1. So because it's negative, you're going to run to the left. So up 1 and then to the left. Okay, so notice every time you make a stair, okay, so very likely it's going to be here at negative 9, by the way, because what makes it 0? What makes it 0 is so you put 0, negative 9. Well, guess what? If you put negative 9, you get a 0, because negative makes it positive 9. Minus 9 equals 0. So there you have it. And when it comes to the first equation, it's going to be a challenge. So because it's not a solid number, but however, 58 divided by 8 will be approximately negative 7. 7.2. Let's go to 7.2. So it's going to be right here. So here's negative 8, negative 7. So it's going to be somewhere here. And so you're rising 5 and running 8. So let's pretend it was at negative 7. So you're going to rise all the way to negative 2 apparently. Okay, because from 7 to 2 is 5 units, right? So it's going to be all the way here, so slightly below negative 2. And I'm going to run, oh my gosh, that's, well, anyway, oh, where are we? Oh, right here. So rise 5 and run 8. So 8 is going to be right here. So if this is negative 9, this is going to be negative 8. So it's going to be right here. Okay, so if I connect the two, I don't have a ruler handy right now, but that's alright. Okay, so, and this is what I get. Okay, so notice this right here is the point of intersection. Sorry. Okay. Anyway, because I don't have a grid formation like this one, it's very hard to pinpoint what that point is. However, there is another way which will be covered by future lessons in this chapter. So why not kill two birds with one stone? Kill two birds with one stone. So I'm going to use a different method. To find the precise coordinates of the point of intersection. So I'm going to keep this for now aside, and I'm going to, so first let me write this down. So let me write this equation down. So I have 5x plus 8y equals negative 58. So this is the first equation, and then 2x plus 2y equals negative 18. So this is the second. Okay, so let me pull it aside because I'm using ink and it kind of shows underneath. Okay, so I'm going to use a different method here, and which is part of the chapter, part of today's work anyway. So I'm going to use there's like three methods. One is called the substitution method, and what we just did was this method right here is called the graphing method. But this is not going to work unless you have a nice, perfect, grid formation where you are presenting the linear functions in a graphing form, much like I just showed you in the book right here, if you know what I'm talking about. Okay, so you see how they determined that it's 3 and 9 because of those boxes. But unfortunately, the answer is not going to be at the crossing point of those boxes along the grid formation. So we're going to use a different approach. It's called the elimination method. So in other words, we're going to eliminate either x or y, so whichever we find it easy. And I think y is the easiest to get rid of because you have an 8 here, and if I have a negative 8 right here, I can get rid of the y. So that means if I multiply the second equation by negative 4, I can make this a negative 8. So again, you can do that because for as long as you multiply both sides of an equation with the same number, everything is fine because you are preserving the balance. Left side equals the right side. So I'm not doing any modification on the first equation. So I'm going to write it as is. So 5x plus 8y equals negative 58. So this is equation 1. And now I'm going to multiply the second equation. Negative 4 times 2x is negative 8x. Negative 4 times 2y equals negative 8y. Negative 4 times negative 18 will be 72. Positive 72. So this is number 2. Okay, so we cancel this, and then when you add those, you get negative 3x, and then equals, when you add those two, you get 14. You get 14. Okay, so when you divide by negative 3, you get x equals negative 14 over 3. So notice we got the x coordinate, and it's not like 2, it's not negative 3, it's not one of those nice numbers, just so that you know. Okay, so because I found one of the two variables, I can use either the first or the second equation, plug in for x, and then I can find the y. So it's up to us which one we pick. It doesn't really matter. So at random, you can say use equation 1, if you like, to solve for y. Okay, so we have the x, so we're going to say 5 instead of x. We're going to plug in negative 14 over 3, and then plus 8y equals negative 58. So notice that we established an equation with one variable, and that's exactly what we want, because we can solve. If you have an equation with more than one variable, well, you are stuck. I mean, and that's why we're able to work with equations with two variables, because we have a system. So we are using 2 or 3 equations, combining them to solve respectively for the x and y in our case. Okay, so I can multiply 5 times 14 is going to give me 70, so it's going to be negative 70 over 3, and then plus 8y equals, and then I can say negative 58 over 1 times 3 over 3, so that I can make this the same, with the same denominator. So negative 70 over 3 plus 8y equals negative, obviously 3 in the bottom, so 3 times 8 equals 24, 3 times 50 is 150, plus 24 is 174. So if we add 70 over 3 on both sides, you get 8y equals negative 174 over 3 plus 70 over 3. So 8y equals negative 104 over 3. So now we need to multiply both sides by 1 over 8. And the reason is to get rid of this 8. And then obviously y equals negative 104, because 104 times 1 is 104, divided by 24. So if you want to simplify any further, you can. We can divide up and down by 4. So 104 divided by 4 equals 26. 26. And then obviously 24 divided by 4 equals 6. Okay. So it seems like we can simplify further, which is good. So 104 divided by 4, yeah, 26. So we can divide by 2 at this point, so you get negative 13 divided by 3. Okay, so we can say solution is a point, so it's going to be x and y. So x is negative 14 over 3, and the y is negative 13 over 3. So that's why we weren't able, you see, notice that this is in quadrant 3, okay? Can you see it right here? So we weren't able to find the actual coordinates of this point, because again, we don't have a grid formation. And even if you did have a grid formation, good luck. Because notice how the coordinates are in a fraction form. So it's not like 2 and 3, for example. Let's say 1, 2, 3, and then 1, 2, 3, 4, 5, for example. You see what I'm talking about? So let's say 3 and 5. See, it would be easy because would be whether you have a grid or not a big deal. I mean, it would be easy to guess. But for this one, good luck. I mean, it's not going to happen. So I'm not sure why the authors of the book even bothered to include this particular exercise, because it would be practically impossible unless you employ some other method, namely the one that we did, like the elimination method. So the solution is going to be this one, and notice that it goes along with the third quadrant. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay, so on the third quadrant, both x and y coordinates are negative, if you remember. Okay. All right, so this is it on this one, but again, we needed help.